Hello. Welcome to session. What are we at? We're at 4. Welcome to session 4 of Python Foundations. Today we'll be talking about a topic that is important no matter what language you're programming in, object-oriented programming. Again, this is session 4, so if you happen to come by here by accident, feel free to watch the former 3 sessions before diving in. Okay. Per usual, I'm going to open up today's notebook in Google Colab. Here we are. And today we'll be discussing a very important concept through all of programming, how to be object oriented. Classes, instances, methods, and attributes. All right, so let's start defining these things. A class is created with the reserved word class. A class can have attributes. You can think of these as characteristics that describe the object. So let's take a silly example. I'm going to use the reserved word class to declare a new type of class called my class. All right, I have a colon, and when I hit enter, I automatically get my indentation, and I'm going to assign an attribute to this class. I'm just going to call it some underscore attribute. I'm going to set it equal to 5. Defining a class in the above way creates what we call a blueprint. We use the class blueprint myClass to create an instance. And after we do so, we can now access attributes belonging to that class. So up until now, we haven't made an instance yet. That's what comes next. So on this line here, I'm creating an instance. And I'm just going to call it instance for the sake of this demonstration. To do so, I call the name of the class followed by the parentheses. And now, once I have the instance created, I can access its attributes, including the one that I defined above called some attribute. And I do that by simply following the object name with a period and then the attribute I want to access. Here we see the output to the cell 5. Now, attributes can be changed. So here again, I'm calling my instance up, selecting the attribute, and then using a single equal sign to reset its value to 50. And so on the second line, we see when I call the attribute back again, that new value is 50. This is very similar to how we were able to reset the elements of a list by indexing the value we wanted to reset and using the equal sign to set it to a new value. All right. So I showed you that example of creating the blueprint, right? Using the reserved word class. Now I want to be a little bit cleaner about how we do this in practice. So in practice, we always use the init function. Notice the 2 underscores, the word init, 2 underscores, and then parentheses, which is executed when the class is being initiated. This is the Pythonic way to be explicit about initializing the attributes of our class. All right. Upon investigation, you will find that the trouble with not using the init method is that your attributes are not guaranteed to be initialized upon creation of the object from the class blueprint. So even though the first example I showed you works, in practice, we always want to use the init method. So how do we do that? I'm going to create the class object in the same way, right? So I use the reserved word class, the name I want to give it, colon. We now define our init method that is called when the object is initialized. So remember when I said we can use a blueprint to create an instance? Well, whenever we do that, by default, the init method is executed whenever we declare the class object. All right, so this is what we're doing here. We pass in the reserved word self whenever we define the init method, and then we reference the current object of the class via that self parameter. And we use that to set its attributes. So looky here, I'm accessing our object via the self alias, putting a period, and then setting the attribute, some attribute equal to 5. All right, so everything that's happening in this cell is the same as above, but we're being Pythonic in how we do it. When we use init, we also have to make use of a special reserved word in Python, self. The self parameter refers to the current instance of the class. In other words, when the object is declared, it will refer to that specific object in memory and not all instances of the class in question. This is yet another Pythonic way of being explicit. Little side note here, what is the special keyword self doing? Do we really need it? Read more about the philosophy of the self by visiting this link. So this link is to a little forum discussion by a major Python contributor. Feel free to read up. All right, let's practice class declaration now in the context of Pokeballs. Really revealing my millennial status here. We have a lot of different kinds of Pokeballs. This is going to help us understand some of the powerful mechanisms inherent in Python classes. Let's start by defining a class to describe the simple, standard Pokeball. It will have the following attributes. Contains, which will be the name of the Pokemon contained in the Pokeball, and the default value will be none. Notice the Python data type none here. It'll have type name, which will be the type of the Pokeball, and its default value will be Pokeball string. It'll have the attribute catch rate, which will be the probability of a successful catch upon throwing the Pokeball, and the default value will be set to 0.5. And the user will not be able to set the value of this object. That is, whenever they initialize it. So more on that in a moment. Let's take a look at how we do this. So I'm going to declare my class the same way we did before, using the reserved word class, the name of the object I want to make, in this case, Pokeball with a capital P, and then a colon. And now inside of the indentation, I'm just going to start by defining my init method. All right, so def init. We always pass along the self parameter. There will be no exceptions to this. And then whatever attributes we want to be accessible to the programmer upon initialization of a particular instance of the object. All right. In my case, I want them to be able, if they wish, to set the value for contains and the value for type name. Even though I'm allowing them to set this, they will still have, what do we remember from yesterday or whenever you last saw the function session? We call these default parameters. So I'll have a default value for contains, and it will be set to none type, the Python none type. And then a default value for type name, which will be set to the string value Pokeball. All right. Now we need to set the attributes of the object via the self. How do we do that? We use the reserved word self. So I'm going to have self.contains equals contains, self.typename equals typename, and self.catchrate equals 0.5. Note how in this case, we're not setting it equal to a variable. We're setting it equal to the hard-coded value 0.5. So this might seem a little weird, right? We're creating these parameters in the init method, but they don't become an attribute of the object until we attach them to the object via the self. All right. Again, this may feel a little uncomfortable at first, but you'll get used to it as you continue to write code in Python. All right. So I'm going to create an instance of my class blueprint. So here's the blueprint. Here's the instance. I'm going to call it Pokeball1. All right. And I'll comment out this bottom line first and show you what Pokeball1 looks like. So we have Pokeball1. I'm going to type a period, and look, I've got 3 different attributes available to me in this object. Pretty cool, right? So I'll just look at type name, for instance, hit execute. I see that it has the default value of Pokeball. Now I'm going to uncomment the second line, right? And I'll go ahead and comment out the first line. Okay, runs no problem, and check it out. Now when I access Pokeball, and let's just take type name for an example, it returns Master Ball, right? Because I set that to the value of Master Ball. To revisit topics from yesterday, what do we call these parameters? They are positional parameters, right? I'm not using a keyword to flag what parameter I'm setting, although I could do that, right? If I wanted to be explicit, I could say contains equals Pikachu, and then type name equals Master Ball, right? Same thing, positional or keyword. Question 1, what are the parameters of Pokeball? Note that were we to run the following cell, we would get an error. Why would we get an error? All right, so this is in line with the question. Let's see what error is thrown. Type error, init got an unexpected keyword argument catch rate. Let's break this down. Notice that what I'm feeding into Pokeball is being sent directly to the init method, right? Whenever we declare a class object, the init method is automatically executed, and whatever parameters were passed to the blueprint are passed to the init method. And here, it's telling us it got an unexpected keyword argument catch rate. If we scroll up, we'll see that when we defined the blueprint of the class Pokeball, catch rate wasn't a parameter for the init method, right? So we're feeding it something that it didn't expect. So in order for this to work, we need to remove the catch rate. And remember, this was a design decision that I, as the user, made. I want the programmer to be able to set maybe a default Pokemon that's contained and maybe a default name for the Pokeball, but I don't want them to hardwire a different catch rate. All right, classes can also contain methods. I'm going to introduce a new method, catch, that is used to catch new Pokemon. It will have a random chance of success, and additionally, it will only work if the Pokeball is empty. All right, so this is a difference between two different things that an object can have. It can have an attribute, which is just some value associated with the object, and it can have a method, which is a function associated with the object. So let's take a look at how methods work. So I'm going to define my Pokeball in the same way as before. I have my init method and the three different attributes that are related to the object. Now, the method catch will update self.contains if a catch is successful. It will also use self.catchRate to set the performance of the catch. All right, so here I'm going to define my method catch, and this is going to look exactly how it looked when we were defining functions, except now they are contained within the class, right? Notice how my indentation here is showing that this is part of the class object. All right, so I'm going to declare it in the same way we do a function using the reserved word def. The name of the function, I'm going to pass along the self parameter. And the reason I do this is within the function itself, I want to have access to the attributes of the object, which I am going to access via the self. I also want it to take in an additional parameter, Pokemon. We'll see what that is in a moment. All right, here's my first conditional. If self.contains is none, then let's try to catch a Pokemon, right? If it isn't empty, we jump down to this else statement down here, and we return the value Pokeball is not empty. Or to be more explicit, we print the value Pokeball is not empty. All right, so now let's look at what happens when the Pokeball is empty. If random.random is less than self.catchRate, then update self.contains to be equal to the value of Pokemon. All right, quick side note here. We haven't talked about the random library yet, but random.random will return a uniform, it operates on a uniform distribution between 0 and 1, and will return some random number between 0 and 1, all with a equal likelihood probability. All right, so the way this conditional works then is about half the time random.random will return a value less than 0.5, and the other half of the time it will return a value greater than 0.5. So half the time this conditional will evaluate to true, and half the time is false, right? So hence 50% catch rate probability. So that's how that little conditional works right there. If it's successful, we print the name of the Pokemon, captured, exclamation point. Otherwise, we print the name of the Pokemon, escaped, exclamation point. All right. We can invoke the catch method the same way we would return the attribute of an object by running object.method, right? So object name dot method name with the parentheses. Note that because this is a method, we use the parentheses, the same way we use parentheses with functions. Inside the parentheses, we pass any necessary parameters. In this case, we will pass the name of the Pokemon we are trying to catch. So I want to double down on this idea. This is going to be very useful as you explore the different libraries in the Python ecosystem. If you're using parentheses after something, that's because it's either a method or a function. If you're accessing something that belongs to an object and you're not accessing it with parentheses, that means it's an attribute. Okay, so here I'm declaring my Pokeball object, and then I'm going to use the catch method to try to catch Pikachu. All right, Pikachu escaped, 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 captured, escaped, captured, escaped. If I ran this 100 times, about 50 of those times we'd catch the Pokemon, and 50 of those times Pikachu would escape. All right. And because Pikachu escaped in this last instance, Pokeball.contains is none. Let's see if we can see what it looks like when Pikachu is captured. All right, so Pikachu is captured, and then we see that Pokeball.contains Pikachu. Question 2, how does catch rate work? How often will success print to the output when we run the cell below? Right, we talked about this up above, but about half the time it will print success. All right. Exercise 1, write a method. Create a release method for the class Pokeball. Again, I've mentioned this before, but if you're watching this video and would like to do the exercises on your own, feel free to pause the video throughout. I will go ahead and solve them while we're working on this recording. Okay, so I've got my class Pokeball. Again, we're creating the attributes. We've defined the catch rate, and now we would like to define a release method. So here, we'll go if self.contains does not equal none, print Pokemon released. And actually, I don't want to have the user have to pass in the name of the Pokemon when they access the release method. So what I'm going to do instead is do self.contains, right? Because self.contains is the name of the Pokemon. And then we'll release it. So we'll do self.contains equals none. All right. And else print Pokeball already empty. And I think we're good, right? So if there is something in the Pokemon, then self.contains will not equal none. And we can print Pokemon released, set self.contains to none. Otherwise, print Pokeball already empty. Let us give that a test here now. So we'll do Pokeball equals Pokeball. Pokeball.catch Pikachu. Let's try that again. All right, it's captured. Now let's do Pokeball.release. Oops, yeah, release. And we have Pikachu release. And now just to last check this, Pokedoll.contains. Right, and nothing's returned because there's nothing in it. Cool. Inheritance. All right. Inheritance allows you to adopt into a child class the methods and attributes of a parent class. We inherit a parent class by passing it into the child class. All right. Pokeball is the parent class in this example, and Master Ball is the child class, right? So when I declare the blueprint for Master Ball, we pass in Pokeball. So remember, the way this looked like before was simply there was a colon here, right? But now I'm adding parentheses and I'm passing in the Pokeball class. Nice. And check this out. I can just have the keyword pass here to let this run without error and not having to write any more code for the class Master Ball. So pass is going to be a super keyword to use as you're developing code. Alrighty. Once we declare an object of the child class, we will have access to all the parent class attributes. In this case, Master Ball will inherit type name of Pokeball from the Pokeball class. So check it out. Yep, there it is. Type name is Pokeball. We don't like that type name because this is not a regular old Pokeball anymore. It's a Master Ball. Let's make sure we change some of the inherited attributes. We'll do this again with the init function. Pause button. You may be wondering, what is the purpose of inheritance? Why is this useful? Well, imagine we went through all this trouble of establishing some baseline methods and attributes of a Pokeball class. When we go to define all those other types of Pokeballs, do we really want to rewrite all of that code? Probably not. And so we can use Pokeball as a baseline via this inheritance method and just change and tweak the things we need to tweak to make the attributes and methods specific to the given type of Pokeball we're creating. So that's the idea here. All right, so we're going to start with Master Ball again, but change a few things. So keyword class, Master Ball, we're inheriting Pokeball, and now we pass into the init method the class attribute values we actually desire instead of just inheriting them from the parent class. So contains will still have this default value of none. Type name now will be Master Ball, and I want a new catch rate. Catch rate is going to be 0.8. And now we'll update the attributes. Notice here that because we're inheriting from Pokeball, we still are going to have the two methods from earlier. The catch method and the release method. All right. But now we have those, oops, got to run the cell. But now we have those specific attributes we cared about, specifically the name and the catch rate. And check it out. We can still catch stuff with Master Ball without having to have gone through all that trouble of rewriting those methods. whoops, master ball dot release. There we go. Nice, Charmander released. All right, now I'm going to introduce two other ways to perform inheritance. This is going to be super important to pay attention to because this is the way things are actually done. So just like I, at the very beginning of this notebook, introduced a naive way to create a class, I have introduced a naive way to do inheritance. Let's look at the more common way that folks do this in Python. Okay, class master ball Pokeball, nothing new there. Nothing new here as well. We still have def init, but now we pass in Pokeball, access its initialization method, and then pass along those attributes that were accessible to the user when they created the master ball instance. So what went away in this? Well, what went away is I didn't actually directly assign those attributes to the self. Rather, we are hitchhiking off of the init method we defined for Pokeball. Again, this can be a cleaner way to write your code. All right, we won't spend too much time here because I want to show the even more common way that folks do this. But just showing that this is all working, right? We still have type name, we still have the ability to catch stuff, even though we didn't assign those things directly to the self up here. We hitchhiked off of the Pokeball's init method to assign those attributes to the self. All right, here's the last way and most common way that we will deal with inheritance in Python. The keyword super will let us write even more succinctly. So here I've got class master ball, it's inheriting Pokeball. I have my init method. It's business as usual up here. Now, super is taking the namespace of the parent class. Note that with this mechanism, we no longer have to pass in the self attribute. So here I've got my reserved method super. It's part of vanilla Python. I'm going to access its init method, pass in contains, and then type name, and then assign catch rate to 0.8. Okay, so what's changed here is when folks put together the super method, it handled sort of circular references that might happen with inheritance. So imagine you're inheriting from something that inherits from something that inherits from something else, and there could be a conflict. You can think of super as a way of dealing with those conflicts, right? So it's got guardrails. So if you're wondering what you should do when you're writing a class that has inheritance, the default behavior you should kind of engineer yourself to fall back on is to just use the super method. Cool. And here, again, I'm just declaring an object from this new version of the master ball blueprint, catching a Charmander, seeing that it was captured. Actually, let's just add in a release. Everything's working as planned. All right, exercise 2, create a class. Write another class object called Great Ball that inherits the properties of Pokeball, has a catch rate of 0.6, and type name of Great Ball. So we can piggyback off of what we did above. I'm going to do class Great Ball. It's going to inherit Pokeball. And let's do init self contains equals none, type name equals Great Ball. And catch rate will be 0.6. Let's do catch. And we'll make this not accessible to the user. Right? We'll use the super init contains type name. And now the super is going to have some pre-processing it does, but then it will pass these parameters to the parent class, Pokeball, so that they'll be properly attached to the self. And remember that within Pokeball, the init method did not take in catch rate. So because of that, we still need to assign the catch rate by hand, for lack of a better term. Here we go. Nice, super concise, right? Looks clean. Let's play with this. So we'll do Great Ball equals to Great Ball. Let's remind ourselves, what am I doing on this line? I am using a blueprint to create an object, otherwise known as an instance of the class. All right, runs fine. Let's do greatball.catch Squirtle. Yeah, Squirtle. Squirtle captured. Hell yeah. Now let's do greatball.release. And we'll do this on a new line. Looking good. All right. Now, interacting objects. As our application becomes more complex, we may have to rethink what methods and attributes are appropriate for our objects to deliver the overall functionality we desire. This is where form and function meet, right? So this is like kind of taking it back to, you'll hear people describing programmers who write beautiful code. There's a lot of thought that can go into how we declare our objects and what kind of information they derive from each other. One of the reasons I think that scikit-learn became such a popular data science library is they were really methodic in how they described objects in their ecosystem. So for instance, any model within scikit-learn has approximately the same API, right? You do model.fit, model.predict, right? And so it makes using their library very easy. So back to Pokemon. Our exercise here is interacting with objects. Write another class object called Pokemon. It has the attributes name, weight, speed, and type. Now create a class object called Fastball. It inherits the properties of Pokeball, but has a new condition on catch method. If Pokemon.speed is greater than 100, then there is a 100% chance of catch success. What changes do you have to make to the way we've been interacting with Pokeball to make this new requirement work? Remember that formerly, Pokemon was a string, right? And now I'm asking you to make Pokemon an object. So not only are we going to have to make a Pokemon class, we're also going to have to rejigger the way it interacts with the Pokeball class. So let's get started. Make a new class called Pokemon, right? Not going to inherit anything. It's going to be its new thing. And what do I need here? I need to define my initialization method. And I'm going to pass in the self. And I'm going to pass in name, weight, speed, type. And actually, before we continue, what do we notice about type when I type it in? Do you remember this from Monday? Monday, whatever day you watched the last session? It returns the data type of whatever is passed along to that function. So this is a reserved word in Python. So something that we can do to escape using a reserved word in Python is just predicate it with an underscore is one thing we can do. So I'm going to do that. All right. So now I am going to, do we want default values for these? Why not? I'll go ahead and make a default Pokemon. So the name will be Squirtle. Or actually, what's that one? Manchuku? Pokemon Machu. All right, I'm going to give up here. It's that big one that kind of looks like a person in boxes. We're just not going to, this is not important. All right, Squirtle it is. And Squirtle weighs 50 pounds. That's going to be an integer. Speed will be 80. And then type is going to be a string. It's going to be water, right? Remember, Pokemons all have different kinds of types here. If you're not familiar with Pokemon, maybe will motivate you to do some studying because it's an important part of our culture. Let's see. Self.name equals name. Self.weight equals weight. Self.speed equals speed. Self.type equals type. The fact that this is highlighting here, even with my underscore at the beginning, makes me nervous. Let's put it at the end. Let's put it at the end. It might just be an IDE bug, but let's see if this works. All right. I don't think we need to, it's not asking us to do anything else besides add these attributes, right? So I think we're fine there. Now we do Squirtle.name, Squirtle.weight, speed, right? We have access to all these attributes. Make sure type works. And then we break type, hopefully not. Type still works. Good. Alrighty. And next part of this, fastball inherits the properties of Pokeball. New condition on catch. All right, let's go for it. So I do class fastball inherits Pokeball. And we'll do def init self, forgetting the attribute self contains type name. Contains will still be none. Type name will be fastball. And we need this here. And then what else do we want? We want super init contains type name. Alrighty. Self dot catch rate equals, what was the default catch rate? Too far up. Default catch rate. I think we're just going to leave it at 50%. So with that, do I need to assign catch rate? I don't think so, because we're just going to inherit it from Pokeball, right? All right, let's make sure this works before we go any further. So we'll have ball equals fastball. Right, always good to dot catch. Let's do Squirtle. Captures, all right, so it's working, right? About 50% of the time. What happens when we try to catch the Squirtle object? It works fine, right? Escape captured. But notice that when we print, it's printing the object stored in memory. It's memory location, not the name, right? So that's kind of indicating to us how we need to change the messaging within class fastball. So let's go ahead and do that. So we'll do def, what do we call it? Catch. And it's going to need the self, and it's also going to need the Pokemon. And then let's think back on how we did this before, right? We need to check whether Pokemon Pokeball is empty. And then we also need to check whether the Pokemon speed is greater than 100. If it is, catch the Pokemon. Otherwise, business as usual, right? So 50-50 chance, depending on the catch rate. All right, let's go for it. If self.contains does not equal none, then proceed. If Pokemon.speed is greater than or equal to 100, then print fprint Pokemon.name, right? Captured. Remember, Pokemon's an object now. Else, if random.random is less than self.catchrate, then print, and I'm just going to steal this. Go ahead and print this. Else, print that they escaped. What am I missing here, folks? I need to update contains, right? Self.contains equal to Pokemon. Now we have an option here, right? Do we want to pass the name or the object? I think that depending on how we wanted to expand the functionality of this class, we might desire for the whole object to be stored, right? So that we have access to its other attributes of the stored object, the Pokemon, I mean. So we'll just set it equal to the actual Pokemon. All right, so this is working all right. We've got if the speed is greater than 100, just go ahead and catch the bugger. Otherwise, business as usual, it's random chance. And then we need to have our else here. Else print Pokeball not empty. All right. Let's give it a whirl. Oh. If it's equal to none, right? If self.contains is none, then do this stuff, right? So now let's see. Underscore not supported between instances of built-in function or method and float. Let's see. What's good practice for us? Random.random. Okay. What did I mention earlier, folks? I said if you're accessing something that belongs to an object, if you use parentheses, you're accessing a function. If not, you're accessing an attribute. So here, I haven't finished calling the function because I didn't use my parentheses, right? So it's recognizing that there's a method object here, but I haven't actually invoked the method function. So we need parentheses around this. Let's try it again. Nice. Squirtle captured. We're getting really lucky there. Okay, now it's escaped. All right, so let's try this again, but I'm going to make speed equal to 100. And let's make sure it's set correctly. All right, speed's 100. So now every time I run this, it should be captured every time. Let's try and test that. So let's just run it 100 times for I in range 100. We'll do this 100 times. And then we'll have if ball dot contains is none, print what? Yeah, so there's no what's there, right? Squirtle captured every time. Okay, cool. Moving on. Let's see. In the above task, did you have to write any code to test that your new classes worked? We will talk about that more at a later time, but for now, wrap any testing that you did into a new function called test classes in the code below. So I will say in this course sequence, Python Foundations, we already had our session on debugging, and we talked a little bit, just a tiny bit about writing tests. We have a designated module for test writing, but it's folded under our data science foundations course sequence. So that'll come later. But for now, let's think of like a simple test that we could write. And I want to clear this out because it's a lot of stuff. All right, so we did this thing where we had a Pokemon with a speed greater than 100, and we wanted to make sure that it caught that Pokemon. So maybe we can write a test for that. So let's call it def test fast Pokemon catch. And we will create a fastball. And we'll create a fast Pokemon where the speed is 100. And then we'll do fastball.catch fast Pokemon. And then we'll assert fastball dot contains does not equal none. And then if that isn't true, print fastball did not automatically catch the fast Pokemon. Otherwise, we'll print test passed. We'll do test fast Pokemon catch, and we get test passed. So I'm not going to spend time thinking of all different edge cases for this, but we can imagine that even if, oh, well, what's a way we can test to make sure this is working for sure? Remember, there's some stochasticity in here, right? Because we had our catch rate still set to 50%. Well, I was going to say we could set that catch rate down to 0. But remember, the way we designed this class object is that we can't, upon initialization, set the catch rate. What's a workaround? We can reset the attribute after it's created. So I can go in here and I can say fastball.catchrate and set it equal to 0, right? So now every time we try to catch anything other than a fast Pokemon, right? Speed greater than 100, the catch will fail. So this is a way to make sure we are testing the functionality of a fast Pokemon catch, which is what we're trying to do with this unit test. Nice, and it's working. So I'll stop there, but as you're working through this, I invite you to think of other unit tests you could write to make sure your code is working the way you think it is, right? How do you test for actually getting a 50% catch rate? Can you think of ways to test for that? How do you test for making sure your Pokemon is released properly on a release? How do you make sure your Pokemon isn't trying to catch something when there's already something, or your Pokeball rather is trying to catch something when there's already something in the Pokeball, right? So these are all examples of unit tests because they are testing a specific targeted functionality of your class. Cool. And that is all I have for today. Let's go back to the course website, look at our program for the day. We have just finished session 4, object-oriented programming. This sets us up to complete the second notebook in the tic-tac-toe project, object-oriented programming in tic-tac-toe. So if you're interested in working on this, navigate to the projects folder and hit object-oriented programming. And now you should be able to work through the tasks in this notebook based on what we've learned today. Cheers and good luck.